Good afternoon, everyone, and welcome to the HELCOM or Baltic Sea Stakeholder Conference on Climate Change. I hope that everyone who has joined has noted that the event will be recorded. This is so that we can later upload this and make it available also to interested parties that were not able to participate today. Climate change, and if you excuse the pun, continues to be a very hot topic, and we can see that by this being the most highly frequented stakeholder conference that we have so far had. We are almost 280 participants here today, and I will be moderating this event. My name is Jannica Haldin. I am the Deputy Executive Secretary at HELCOM. I work with issues that are related to monitoring and biodiversity status assessments in many of the forums that we're doing them on a regional level, including status of the environment, but also status of biodiversity. And of course, I work with climate change. I will outline the program for today. We will start with some opening remarks. These will be presented by Sebastian Unger, Markus Reckermann, and Rüdiger Strempel, who I will present in more detail when we get that far. Then we will start to dig into climate change a little bit deeper and look at climate change in the Baltic Sea and the state of affairs as we know them at this point in time. This will focus on the climate change fact sheet that HELCOM has produced jointly with Baltic Earth, and also at the outcome of the fairly recent workshop on blue carbon in the Baltic Sea region and the potential of blue carbon as a mitigation tool towards climate change. Then we will have a break. And once the break is over, we will come to the presentation on climate projections for the Baltic Sea region. So not just where are we right now, but also where might we be heading in the future. Now, once we've gotten this far, we are moving on to a more dynamic part of today's event in the form of a panel discussion. In the panel discussion, we will have representatives from many different levels of policy and governance, but also from civil society and the national perspective. But it's important here to remember that this is, after all, a stakeholder conference. And as a stakeholder conference, you as stakeholders are a really important aspect of the discussion. And to enable more dynamic kind of interaction with you as participants in this event, while still managing such a large turnout, we have enabled a questions function, which you can find at the bottom of your screen. Now, this Q&A function allows you to present questions both to the presenters, but also to the panelists during the panel discussion. And then I will take up as many of those as we have time for. There is also a possibility to like or vote for questions that other people have posed. And this you do by using the little thumbs up icon that you can find once this question starts coming in. This is also a way for both the panel and me as moderator to see which questions might you be most interested in getting answered or discussing in this event, and thus make sure that we cater to you as stakeholders as far as possible. Please note that there will be no answering the questions in text, because we want the panelists to be able to focus on the discussion and the kind of create a dynamic event. So we will unfortunately not be privately or publicly answering the questions in writing in this event. With that, I would like to once again welcome everyone and pass the microphone, the virtual microphone, over to Sebastian Unger, who is first Marine Commissioner for at the Federal Ministry of the Environment, Nature Conservation, Nuclear Safety and Consumer Protection of Germany, for his opening remarks. Sebastian, please.
Thank you so much. I hope you can hear me. It's a really great pleasure and an honor to speak to you today. It's one of the first official appointments that I have in my function as Germany's first marine representative in the Ministry of the Environment and for the federal government. And I'm really happy to do this here on this occasion since the HELCOM cooperation and this very topic is so close to my heart. And it's fantastic that we have this great turnout, so many participants. It would have been, of course, much nicer to come together in person, but perhaps it's a good sign also that so many people use this virtual opportunity to exchange on this really important topic. You all know that we depend on a healthy ocean, and the ocean is turning high, it's rising sour, and it's getting warm, and all these are effects that are also very visible already today in the Baltic Sea. And we have this triple climate pollution and biodiversity crisis that together really have a huge impact also on the Baltic Sea marine environment. Healthy ocean, as you all know, are really key allies in our fight against the climate crisis. Ocean protection and climate protection really need to go hand in hand. The ocean regulates the climate and is a natural carbon sink, and so is the Baltic Sea. And degradation of these ecosystems, for example, through fisheries, through destruction of benthic habitats, can, of course, create the release of additional greenhouse gases. We will tap this natural potential in our government in Germany. We have launched a new national action plan for nature-based solutions for climate and biodiversity. And the good news is that it also includes a program for marine blue carbon, for example, to protect and to restore when necessary habitats such as seagrass beds or salt marshes. And with that, we do not only want to help protect the climate, but also simultaneously protect the marine biodiversity. So that this is really a win-win for both climate and marine conservation. As the new special representative for the ocean of the federal government, I will do everything within my power in working towards an effective protection of our seas. And with that, I want to intensify the involvement and also the cooperation with environmental and nature conservation associations, with Germany's marine research and the various user groups. And I think one of the keys is really to work across the different sectors and to support integration between these different actors and sectors. And I'm so happy to really see so many of those different sectors also being represented today in this discussion on climate change in the Baltic. Germany will significantly boost marine protection with a marine campaign. We call it Meeresoffensive. One of the first components also of this reinforced engagement for the ocean has been also Germany's engagement with the G7. And some of you might know that we have launched an ocean deal together with our partners. And this was endorsed by the heads of states and governments at the G7 summit in Elmau. We continue implementing our measures at regional and national level, for example, through a national marine strategy. And of course, we have to hold the loss of biodiversity in our ocean. This is really one of the key challenges. And we will work with our partners to protect 30% of the global ocean by 2030. And we want this to be really one of the key goals that we will lay out at the next COP of the Convention on Biological Diversity to take place in Montreal in December. And this very goal, and this is why I'm mentioning it, it's discussed and agreed at the global level, but it will trickle down to our work here in the Baltic Sea region. And we will work very much and very hard to adopt this legislation, of course, according to the EU, but also to really make it an implemented goal in the Baltic Sea. And you know this so much better than I do, how much progress has been achieved already, thanks to the good cooperation within HELCOM, but also, of course, through the European Union and in other regional seas, like, for example, the OSPAR Convention. The German HELCOM chairmanship was, and we can see also today, still is difficult due to the COVID pandemic and the terrible war of Russia against the Ukraine. And we are, I am very grateful to my colleagues who have handled the presidency so well and guided HELCOM contracting parties through those challenging times, with the excellent support also of the fantastic HELCOM Secretariat and the trusted cooperation among the different parties and HELCOM's neighboring states in the Baltic Sea region. Let's look at some highlights also that you have achieved, that the HELCOM family, let me call it like that, have achieved together. There was in 2021 the successful update of the Baltic Sea Action Plan. Member states have come up with an ambitious plan for the coming 10 years to achieve good environmental status of the Baltic Sea. And in addition to actions, for example, against eutrophication, pollution, one important step was made in bringing together climate and marine protection. And one of the, I'd say, steps towards that important direction is this workshop today. Upcoming challenges that we are seeing is to really seek for a resilient Baltic Sea that is fit to cope with climate change effects. I see this cannot be stressed strongly enough, and these actions that are laid out in the Baltic Sea Action Plan will help us to really get progress achieved in this important pathway. HELCOM has been active since 1974, so for almost 50 years under various difficult and variant political situation. And despite many successes since then, we all know much needs to be done to achieve the target of good environmental status of the Baltic Sea by 2030. But I'm really happy to be part of this HELCOM community and very much look forward to face the challenges together with all of you. And I wish you all a very successful meeting today. I will try to stay as much online, but I have to apologize that I will have to drop out a bit here and then and have to leave the meeting earlier due to other commitments. Thank you very much.
Thank you very much, Mr. Unge. And thank you for bringing the global perspective also into this discussion, because this is, of course, a global challenge for which we might need to take then regional and national action. So, and on the regional perspective, I would like to hand over to Mr. Markus Reckermann, who is the head of the International Baltic Earth Secretariat. Baltic Earth is a partner in the and represents the research community around the Baltic with regards to climate change and other impacts from human activities. Markus, please. Markus, you are muted.
Okay, I'll try again. Okay, sorry about that. Thank you, Jannica. It's a pleasure for me to say a few words on behalf of Baltic Earth. And I would like to take this opportunity to give a brief overview over our collaboration, which has lasted for almost 20 years now. So before I come to that, let me just briefly explain what we are and what we do. Baltic Earth is an international and interdisciplinary network of researchers and institutions around the Baltic Sea region, striving for an improved Earth system understanding of the Baltic Sea region to support science-based management. We organize publication projects, workshops, conferences, but also summer and winter schools. Climate science is a strong but not the only focus of Baltic Earth work. So now to our common history. Baltex, which was the predecessor of Baltic Earth, was established in 1994 as an international program to foster research in the fields of meteorology, hydrology, and oceanography in the Baltic Sea region. But soon the scope was extended to regional climate science, and Baltex soon established a strong expertise in regional climate science, including regional coupled modeling, that is the integration of atmospheric and oceanographic processes into the models. So around 2004, the idea evolved to make the knowledge, which is distributed in many hundreds of scientific papers, better available to the scientific and to the stakeholder communities. So, and it turned out that around that time that Baltic's scientists started preparations for this so-called Baltic's Assessment of Climate Change in the Baltic Sea Basin, short BAC. Many of you may have stumbled over this term already or even have looked at the books. Around that time, HELCOM felt the need to include climate change effects into their work. So contacts to the HELCOM Secretariat were made very quickly by Helsinki-based Baltic scientists, and the collaboration was established in 2004, which lasts to this day. And in order to deepen the collaboration, staff of the HELCOM Secretariat was invited to join the Baltics steering group in 2007. That was first, it was Jukka Marko Leppänen, then it was Maria Lamanen, Ulla Lee Zweifel, and now it's you, Jannika. So in 2007 and 2013, two HELCOM thematic assessments on climate change in the Baltic Sea area were produced, and they were based on the two BAC books. So when Baltics evolved into Baltic Earth in 2013, it was the time for some changes, and the new approach was to allow more interdisciplinarity and include also other anthropogenic and non-climatic drivers into the assessment work. So it was decided to produce a collection of assessment papers on the different Baltic Earth topics, the so-called Baltic Earth Assessment Reports, or short BEAR. They have now been published this year as open access in Earth System Dynamics, and they describe the current state of science in the different fields of Baltic Earth. The climate change assessment paper in this collection is outstanding, as it summarizes and updates the current state of climate change knowledge in the Baltic Sea region. And we will hear a little bit more about that later. So at the time that we were preparing the BEARs, so these assessment reports, HELCOM felt obviously that it was also time for a new format in communicating climate change impacts on the environment of the Baltic Sea area. So in 2013, the HELCOM Expert Network on Climate Change, or short NCLIME, was established, with Baltic Earth scientists prominently contributing. So the outcome of this joint effect is the HELCOM Fact Sheet, Climate Change in the Baltic Sea, which was published in 2021, and which is available to all of you via the HELCOM website and also the Baltic Earth website, baltic.com. It is based on the BAC and BEAR work and the expertise of all the NCLIME scientists. And that will be presented here by Baltic Earth and NCLIME chairperson Markus Meyer here in a few minutes. Kleiner Hinweis an unsere deutschen Teilnehmer, das Factsheet gibt es jetzt auch auf Deutsch. So sorry for this short German interlude, but it is also now available in German, the Factsheet. So let me come to the conclusion. Baltic Earth and HELCOM have complementary roles in the scientific and political process. And in our view, it can serve as a role model for channeling scientific findings into the regional political process. So thank you, Rüdiger. Thank you, Annika, and all the other HELCOM staff. And let us continue the fruitful collaboration. And let us now have a good stakeholder conference. Thank you.
Thank you very much, Mr. Eckermann. So now we have touched on global policy, which of course drive how we approach climate change and climate change adaptation and mitigation. And we've touched on the importance of like the scientific community and scientific underpinnings of all of these actions that we're planning to take. So somewhere in the middle here, we then have our regional cooperation. How do we take this scientific information to guide our decision-making on a regional level, while at the same time picking up on all of these global commitments and global policies that we both regionally and nationally have committed to implementing. And on that note, I will hand over to the Executive Secretary of HELCOM, who very much represents the regional policy aspect of this, Mr. Rüdiger Strempel, please.
Thank you, Annika, and good afternoon. Can you hear me? I have an echo here. Okay. Thank you, Annika. Good afternoon, everybody, and welcome to this year's Baltic Stakeholder Conference. The downside to being the last in line, of course, is that everything's already been said. The upside in this case is that I'm actually quite glad I was last in line, because we had some technical problems, and had I been first in line, I wouldn't have been here. So with that, I'd like to welcome you all to this conference, and I'm very happy you turned out in force, because of course the 2022 Baltic Sea Stakeholder Conference, or Baltic Stakeholder Conference, is dedicated to a highly relevant issue, the issue of climate change. And after a summer of record high temperatures, and remember we had 40 degrees for the first time ever in the UK, after a summer of devastating forest fires and droughts in Europe and North America, and catastrophic flooding in Pakistan, to name just a few of the incidents we witnessed this summer, and now a spring that already promises to be way too hot in Australia, because yesterday I learned that it's already 40 degrees in Australia and spring is only beginning. What could be more topical than climate change? And for those who might still be doubting, and I know there are none of those here today, I'd like to quote the recently published report of the IPCC Working Group 2 on impacts, adaptation, and vulnerability, which provides some compelling additional evidence. And I'd like to quote just one sentence from it, which is not very encouraging, because it says, climate change impacts and risks are becoming increasingly complex and more difficult to manage. So this, of course, will add to our woes. Now, the Baltic Sea, beautiful though it is, of course, is no Shangri-La when it comes to climate change. Climate change has arrived in our region and will continue to make itself felt, and increasingly make itself felt around the Baltic Sea. And that's enough gloom and doom for one meeting. I'd now like to turn to the positive side of things. Looking at the bright side, the problem is acknowledged in our region, and it's being addressed in the Baltic Sea region as a whole, and specifically also by HELCOM, and we've already heard some of what is being done. The Climate Change Fact Sheet, of course, is a case in point, and the HELCOM Ian Klein, which was established in 2018, and masterminded all of this, is another case in point. But then so is, and this is what I'd now like to turn to, the Baltic Sea Action Plan. The Baltic Sea Action Plan recognizes climate change as the overarching issue that it is, and actually dedicates a section to it in the horizontal action segment, which contains 5 specific actions specifically geared to address climate change. It also contains a further 5 actions which are directly related to the climate in the sea-based activities segment. Moreover, the Baltic Sea overall is, of course, aimed at achieving a healthy and resilient Baltic Sea ecosystem. And a healthy and resilient Baltic Sea ecosystem is one that is, of course, equipped as well as possible to deal with the impacts of climate change, so that we can say that all actions contained in the Baltic Sea Action Plan contribute, in a manner of speaking, to addressing climate change. And in doing that, of course, we're not just working for the Baltic Sea region, we're also contributing to global efforts, be it in the context of the Paris Agreement under UNFCCC or the Sustainable Development Goals. This is all very well, but of course more needs to be done. And this is also evidenced by the Climate Change Fact Sheet, which has been cited several times already today, which shows us that we know a lot, but we need to know a lot more. Luckily, the Baltic Sea region is blessed with a vibrant civil society and a highly competent and broad scientific and research community. And we're privileged to be able to tap into all of this expertise and all of this competence and to look to the support of these segments of society. And that means to you in seeking to address and better understand the impacts of climate change on our region. And that, of course, is where this BSC now comes in. And I look forward to having a fruitful conference, an inspiring discussions and panel discussions and whatever else we have, workshops tomorrow. I'm looking forward to gaining insights from all of you and to all of us sharing insights amongst each other. Thank you for being here today and welcome once again.
Thank you, Mr. Strempel. And as we can hear, there is a need to take action, but in order to actually understand what action we need to take, we need to understand what changes are already happening and what can we expect in the future when it comes to the effects of climate change. For this, we will dig deeper now into the actual climate change fact sheet. And I would like to remind everyone who is taking part that you have the opportunity to post questions using the Q&A button at the bottom of your screen. Also during the presentations, we could take these up in the panel discussion later if there is enough time. So if something arises that you would like to know more about or need clarifications regarding, then please post your question using the Q&A button at the bottom of your screen. And I would like to now hand over to Mr. Marcus Meyer, who is the chair of the Baltic Earth Science Steering Group, and also the co-chair of the Expert Network on Climate Change that is shared between Baltic Earth and HELCOM, and has been instrumental in developing both the process and the actual process for and the actual climate change fact sheet itself. Please, Marcus, go ahead.
Thank you very much, Jannica. Ladies and gentlemen, I would like to introduce the fact sheet now to you. And for that, I would like to share my screen. So I hope that you can see my slides. The fact sheet that was introduced already before, and that has been done in collaboration between the Baltic Earth Science Network for Earth System Science for the Baltic Sea region and HELCOM. So also mentioned already, the knowledge base are the assessments that has been done since quite a long time ago by the Baltics and Baltic Earth, the network on the Earth System Science in the Baltic Sea region. Earlier these assessments were called the BAC books. Now it's the BEARS, the Baltic Earth Assessment Reports, published this year. It's a special issue with 10 articles, 109 co-authors from 14 countries collaborated and wrote these review articles. And what is produced here is a review of our knowledge about processes and changes in the Baltic Sea Basin from more than 2,800 different scientific articles and institutional reports. So you can download it. It is open access. One of these articles is called The Climate Change in the Baltic Sea Region, a summary. And it's the knowledge gain actually since the last update published in 2015. So it's all the reviewed articles from 2013 onwards. 33 parameters from the atmosphere, the cryosphere, the land, the terrestrial biosphere and the marine biosphere, the sediments, and so on, but not the anthroposphere were included. And past, present, and future climate changes were addressed. 47 scientists contributed to this particular work, and on 137 pages. So quite a lot of material. And this is actually not really so easy to get into everything, because there are scientific articles. So therefore, it was the idea in the collaboration with HELCOM to produce a fact sheet that is easier digestible. It's a climate change fact sheet published last year. And the aim is to provide information, for instance, for marine spatial planning, but also for climate adaptation in the region. Or Rüdiger mentioned it already, the Baltic Sea Action Plan. So for instance, nutrient load abatement strategies that has been in place for some time in the Baltic Sea region, but that need to be revised under the aspect of climate change. So warmer climate, warmer water will require a larger reduction to make it brief. So with this task, the production of the fact sheet, the NCLIM network has worked on. So the fact sheet starts with some background information, a map showing the regional future climate changes for selected parameters under a medium emission scenario. I will explain later what that is. Also some parameters, actually 34 variables have been addressed, not identical, the one from a bear, but there's a large overlap, directly affected by climate change and the indirect affected parameters by climate change. For each of the parameters, you can find a short description, what the parameter is about, what we know about past and future changes, our knowledge gaps, policy relevance, and then references. And of course, this is going back then to the 10 BEAR articles. More than 100 scientists contributed, and everything was coordinated by the HELCOM Secretariat. It was published last year. And as Markus Reckermann already pointed out, there's now even a German translation available at the Baltic homepage. Just to give you a flavor, you need not to read, of course, all the text here, just how it looks like. Here's this map showing the projections for the individual basins. The small symbols show the different parameters. For instance, the thermometer is a symbol for the water temperature, and you can read, inform yourself what is going to happen under this projection RCP 4.5. That means representative concentration pathways 4.5, which is somehow a mean projection of the last IPCC report. This is important to note. We have now the 6th assessment report, but the fact sheet is based on the 5th IPCC report, because the regional downscaling of the results from the Intergovernmental Panel of Climate Change, it takes some time actually to perform that, but I think all the information is still very much up to date. And this downscaling is important because the IPCC reports do not provide the specific information for the Baltic Sea region. There is also a graph like this one showing the 34 parameters and all the interactions. The parameters are categorized in cycles, so the energy cycle, the water cycle, and so on. And there are a lot of connections. So you can imagine if there's a change in one of these parameters, say air temperature, then it affects the system in a complex and highly nonlinear way. And with this problem, we have to deal with. The parameters are have some statements, of course, so some concluding remarks on our knowledge, and these are evaluated with confidence levels. There are 3, and this system follows actually the IPCC procedure with an overall so a 3 overall confidence limit according to agreement on consensus and evidence, so the type, amount, and quality. So if evidence is high, several types of evidence, say data sets and models, agree on upon each other, and many scientific articles are available about a certain statement, then the agreement is high. So I will show you now some selected examples from the fact sheet, and we start with the surface water temperature. Here shown is for the past 4 decades, the surface water in the Western Baltic Sea, to be more precise, the Acuna Basin and the Dar Sill, from 3 different data sets. There are in the bars in gray are from the monitoring program that is established since more than 100, was established more than 100 years ago, from a fixed station at the Dar Sill, and from the central Acuna Basin, the Marnet stations in red. And you clearly see that the past 3 decades has been exceptionally warm. This is not proof, because it could be still multi-decadal variability, this warming in the past. But if we prolong the record that you see here further back in time based on the historical monitoring data, it is clear that this past 3 decades are exceptionally warm, and there is no other period, was no other period before as warm as this one. This affects also sea ice, so the overall warming affects the sea ice. The annual maximum sea ice extent that you show here has a very large fluctuations. Warm and cold winters fluctuate and pass each other. So it's hard to see any systematic changes, but if you look at 3 30-year periods, the recent decades, and compare it with some 3 decades 100 years ago, you see clearly that the distribution changes. So when we had earlier most frequent medium winters, and then even a lot of winters where the entire Baltic Sea is frozen, that is shown in the lower right panel. And we have, compared to that, we have today not these very severe winters anymore. Its distribution is more shifted to the warmer, to the milder winters. Also, precipitation increases, but actually not overall in the Baltic Sea region. It's hard to detect that. So what is seen here is the river discharge from 4 Swedish catchment basins, because from the Swedish, from these Swedish basins, we have a quite good database. What you can see clearly that in the north, in the Bottom Sea catchment area, there's obviously a wetter condition. Overall, the total river discharge to the Baltic Sea does not show any significant trend during the past 100 years. So it seems that the recent warming has increased the hydrological cycle in the north, but not everywhere in the Baltic Sea catchment area. This affects salinity. What is salinity? Well, it's grams salt in 1 kilogram of seawater, and it's an important parameter describing the dynamics in the sea, because it describes the density. More saline water is dense, more dense, and that affects the currents in the ocean. But in addition, also the ecosystem is very much dependent on the salinity. You have freshwater species and marine species. And the Baltic Sea in the transition area between well, the freshwater systems to in the very north and the very east, and the very more marine conditions in the Baltic and in the Baltic Sea entrance area. described. So there's a strong gradient in the Baltic Sea, and any change in this system affects dramatically the species, the ecosystem. What you see here is the sea surface salinity. There is a pronounced multi-decadal variability during the past 100 years, both in the observation, that are the gray dots, and in the reconstruction, this is the red curve. But there's no overall trend. So that fits a little bit to the statement that I did about the total freshwater input to the Baltic Sea that increased in the north, but not in total. Sea level has gone up. To the right, you see 14 Swedish marographs from 1860, and here lump uplift has been subtracted. You clearly see that from this record, about 20 centimeter increase compared to more than 100 years ago. But this is compensated, of course, due to the land uplift shown to the left. The largest land uplift we have in the northern Baltic Sea, close to the city of Luleå, and approximately a zero line in the southern, very southern end of the Baltic Sea. And this has to be combined. So in the north, there is still the land uplift is larger than any sea level rise, either the observed and as I will show in a minute, also the projected one. Or if you take spatial averages of station, then you can indeed prove an almost statistical significant acceleration of the sea level rise that was projected and expected. But in individual stations, it's not possible to see that. So what about the projections? I come back to the parameters that I've introduced already. We start with the sea surface temperature. These maps show changes for the end of the century compared to a historical period, 1976 to 2005, for the 4 seasons, winter, spring, summer, and autumn. And then we have the already mentioned RCP 4.5. So I call it a medium emission scenario, which could be a little bit misleading, but somehow to indicate what that really means. And a high-end emission scenario, that is the lower row of this matrix, the RCP 8.5. It doesn't matter really so much. So more emissions means larger warming, of course, but the patterns of these two scenarios are actually pretty much the same. So we find the largest warming during summertime in the north, in the Botnian Sea and the Botnian Bay. So right after the ice melt, which is actually occurring in a warmer climate earlier, the water warms more and gives rise to larger changes than compared to the southern Baltic Sea. For the annual maximum sea ice extent, we find a similar, well, an expected decline in sea ice extent. You have the 3 colors in these maps, the historical period, 1970 to 1999. And then the medium and high-end emission scenarios by the end of the century in green and yellow. And actually this has been performed with 2 different models. And what you can see that both models agree in the result that the northern Baltic Sea, so the Botnian Sea and the western part of the Gulf of Finland is getting ice-free independently of the emission scenario. When we go to river discharge, I told you that we expect an increase in precipitation in the very north. It's more a decline in river runoff from the southern basin, but in total, the projection suggests an increase. It's a large spread in different projections that you see here. in medium and high-end emission scenarios of a number of models indicated by the various line types, between, say, 2 and 20% at the end of the century in increase. So the models have here actually a large spread indicating uncertainty. And this has consequences for the salinity, the same plot as before, but now for the parameter salinity. And this is, to make it easy, averaged over the entire Baltic Sea. Then you see both an increase and a decrease, and you cannot even distinguish between the medium and the high-end emission scenario. So a large scatter, and the conclusion is we cannot say anything about the robust change of salinity. Why is that? Well, in addition to the increasing freshwater supply from the northern part of the Baltic Sea, the sea level is rising, which is also not the exact numbers are unknown or have a large uncertainty in the projections. So a higher sea level rise will mean a higher sea level above the entrances of the Baltic Sea, so a larger flow of salt into the Baltic Sea, counteracting the effect of freshening from the north due to increased river discharge. So the mean sea level in the Baltic Sea is projected to rise. This is actually a figure from the last IPCC report, the 6th assessment report, with the different emission scenarios in different colors. We need not to go into detail. So approximately there is a projected increase between 50 centimeters and 1 meter, but it is for the figures for the end of the century. If you look to the right, then you see the global mean sea level change in 2300 relative to 1900, a large scatter, but much larger numbers. So the system is inert, giving rise to additional sea level rise, even in the case if we follow a mitigation scenario like the Paris Agreement. We can note that the Baltic Sea level is projected to rise slightly less. That has to do actually with the gravitational impact from Antarctica, from the ice sheet changes in Antarctica, but it's approximately following the global mean sea level. And that is the reason that I told you before for the increase, the increasing part in the salinity that counteracts the increased river discharge. Sea level extremes, you can find in the literature both articles arguing for projections about an increase in sea level extremes and for no changes. Actually, when we look careful, and as an example, I show you here 4 different stations for the different parts of the Baltic Sea, then there is no robust trends in extreme values of sea level relative to the mean sea level. So the grayish range is actually the level of noise, and the changes are the colored curves, and they are almost doing all months within the noise level. So we cannot argue for systematic changes that might be different at individual places where actually maybe projections might indicate even for directional changes, but as a overall conclusion, there are no changes relative to the mean sea level. Of course, the mean sea level is increasing, and with that also the extreme values, but not on top of that, so far we know. So the combined effect of temperature increase, of nutrient supply to the sea, and stratification causes in the sea oxygen depletion, because the organic material that is produced during blooms and that is falling down to the sea bottom is consumed by bacteria. And you find something like this, the dead sea bottoms without higher forms of life due to the oxygen consumption. And these areas are quite extended in the Baltic Sea. And this started with the period of eutrophication, so the intensification of agriculture after World War II and the increase in population and related sewage water increase to the Baltic Sea. It's the reductions of these hypoxic areas or dead zones, dead bottom zone. This function looks like a step function to nowadays very high levels. And if we go for the projections, then of course we need to define also what kind of nutrient load scenarios we assume. Do we follow the recommendations of HELCOM within the Baltic Sea Action Plan, that is green, or do we follow some reference conditions of nowadays levels, or even a worst case where the population is even more growing and additional nutrient loads are released? And these scenarios actually have been combined with the warming effect. So the conclusion of this scientific exercise is that the overwhelming effect for hypoxic area are the nutrient load, the future nutrient load to the Baltic Sea. But there is a counteracting effect of the increasing water temperature and decreasing oxygen concentration in the Baltic Sea. Even in the case of the Baltic Sea Action Plan and the good development that we had in the past years, it takes some time. It is possible to come back in 2050 or something like that to the situation of the 1960s, but it will take some time. So the Baltic Sea is a slow system. We accessed in the fact sheet also indirect parameters. These are parameters that are indirectly affected by climate change, but they are also affected by other drivers. For instance, shipping. There's obviously an increase in shipping that we can expect in the future to ice-free sea areas, but other drivers like economic settings are more important or might be more important than these changes in ice coverage. Water birds shift more to the north in their breeding and wintering areas. That has been observed in the past, and that is expected to go on also in the future. And the ring seal population, which is one of the 4 marine mammal species in the Baltic Sea, are expected to decrease because for the reproduction, the ringed seal need sea ice. In summary, and this is a busy plot as well, but I still would like to show you this because you can draw some overarching conclusion. These are the parameters actually from the Bear report. And there are less errors than compared to the plot that I've shown you at the beginning of my talk, because it's the attributed changes that are shown here. So I need to explain more in detail. So you have the different parameters like air temperature. And then you have changes in black and in red. And these changes are past changes in black, and confident are 3 pluses. And in the future, the red pluses. So if it is less confident, then there is only 1 plus or maybe 2 pluses, or if it is a negative change, the same with minus signs. And if there is no sign at all, then we do not know what's going on. The driver of the system only related to climate change is the increase of atmospheric CO2 and other greenhouse gases and aerosols. Aerosols are counteracting by cooling the temperature. That drives the air temperature. And if we then look at one of, say, the gray bubbles, that is the cryosphere, for instance, the snow on land or the glaciers or the sea ice on the Baltic Sea, then we see there is a clear decline in sea ice, so 3 minus in the past and 3 minus in the future, and it can clearly be attributed to air temperature. and so on and so on. The other cycles are in the water cycle, for instance, in blue, or in yellow, the momentum fluxes. And what you can see here, there are a lot of black arrows, so we can actually see the consequences of the warming in many parameters. But the other parameters of the Earth system are less affected by the other parts of the Earth system cycling, for instance, the water cycling. And that means simply that our knowledge about the attribution is incomplete. So this is one of the basic solutions. The air temperature warms, with that, of course, the water temperature, and has large impact on all parameters of the cryosphere. It has effects even on the marine ecosystem, that is the light green bubbles here in this. And but for the other interrelationships, we have less confidence. Okay. I would like to sum up. We have some selected results that I presented. For instance, the scenarios for the Baltic Sea projected sea surface temperature increase of between 1 and 3 degrees Celsius in the annual mean by the end of this century, compared to the historical period 1976 to 2004. And this range is actually an ensemble mean for the different emission scenarios, RCP 2.6, what you can regard as something like the Paris Agreement. And the high-end scenario is then closer to 3. In the future, it's very likely that the maximum sea ice extent will further decrease. I have shown you that it is rather independently actually of the degree of warming, but we can be quite confident, and all the projections point to that the Botnian Sea, for instance, will be ice-free. Due to the large uncertainty in projected freshwater supply from the catchment area, wind and global sea level rise, salinity projections show a widespread trend. And there's no robust change that we can identify. So this is, of course, a pity, because salinity is such an important parameter for the Baltic Sea in general, and for the Baltic Sea ecosystem. But the drivers point to different directions. So increase in the freshwater supply from the northern catchment area, and increase in the global sea level rise will cause an increase in the salinity. But the net effect, we do not know. The global sea level will rise. How much, we do not know. It depends very much on the global processes that are involved, for instance, the melting of the Antarctic and Greenland ice sheet. And consequently, the Baltic Sea level will follow this global development as well, a little bit less maybe than the global average, but basically follow the global sea level rise. This is counteracted by land uplift in the northern areas. So there we have perhaps even in under the more pessimistic scenarios and larger land uplift compared to the projected sea level rise, but it matters, of course, for the southern Baltic Sea. So I would like to thank you for your attention. I would like to thank all the contributors that have contributed to this work. These are the Baltic Earth colleagues within the BEAR project, but also the colleagues that contributed to EndClimb. And last but not least, I would like to thank you, the HELCOM Secretariat, that helped with the coordination of this fact sheet. So thanks a lot.
Thank you, Mr. Meyer. And I would like to repeat that for much of what was presented here in this presentation, the climate change fact sheet provides these key message summaries. So essentially, what we know is summarized in about 100 words, but it also provides some more information for each of these 38 topics. And the 38 topics are divided across these physiochemical parameters, the ecosystem parameters. So this is, for example, species and habitats and so on. And then also human use parameters that explains what might we expect for some of the aspects that are directly relevant for us as a society. And for each of these, it provides a brief description that should be quite easily digestible. It provides information on what is already happening, both when it comes to what is the mean change, so kind of what is the gradual change that we see over time, but also what does it mean with extremes. For example, it can, if it rains a little bit more over a long period of time, we might not be affected in the same way as if we get an entire summer's worth of rainfall in 3 hours, which, for example, happened in Finland this year. And then it also looks at what can be expected in the future. And again, this is also presented both with the mean change and the extremes. It outlines what the knowledge gaps are. So it presents what we know, but it also presents what we don't know. And this is very important because it explains where we should put our efforts in the future if we want to have a better understanding by the next time that we're looking at climate change fact sheets. And then it presents the policy relevance. So what should we actually do with this information now that we do know it? And the climate change fact sheet is available under publications on the HELCOM website and is open to everyone. Now that we have an overview of what changes are happening and where we might expect to go in the future, the next speaker will talk to us a little bit about what might we do to change that, and especially in the form of blue carbon in the Baltic Sea region. So this is excerpts from a blue carbon workshop that HELCOM arranged in 2021, and it will be presented by Ms. Manuela Krakauer, who is the scientific officer at the German Environment Agency, UBA. So Manuela, please.
All right. Thanks a lot, Jannica. Good afternoon, dear colleagues from scientific and governmental institutions, as well as from HELCOM bodies, the interested stakeholders of the Baltic Sea region and beyond. Ladies and gentlemen, with my presentation today, I will give a short insight into the results of the HELCOM Blue Carbon Workshop, which was held in 2021, as Jannica already mentioned. My name is Manuela Krakau. I'm a marine biologist at the section Protection of the Seas and Polar Regions at the German Environment Agency. And I today also speak on behalf of colleagues from UBA and also from BFN, which is the German Federal Agency of Nature Conservation, which were also involved in co-organizing the Blue Carbon Workshop last year. All right, what can you expect in the next minutes? I will introduce the setting of the workshop with a quick background description, including a link to the German HELCOM chairmanship. I will focus on two aspects of the Blue Carbon Workshop, namely a selection of the compiled projects and initiatives, as well as the discussed conditions for blue carbon habitats in the Baltic Sea region. Finally, I will give a short summary and an outlook from our perspective So
Manuela, excuse me.
Yeah.
We can see your slides, but not in presentation mode. So we are actually seeing only the first slide now. You're in your
all
opening
right. We
slide.
had the test and then it worked, but not today, not now. I will try to do it again.
Okay, now at least now we see the background slide, but still not in presentation mode, but we do see it. Can you all see it full screen, no notes?
Yeah, that looks good.
Okay.
All right. So yeah, go through the yep. All right. So I will hurry up and go back to setting the scene. Markus Meyer just mentioned already Paris Climate Agreement from 2015, which also includes states around the Baltic Sea and gave the commitment to ambitious greenhouse gas reductions and implementation of necessary measures to achieve them. And one part also, the IPCC reports showed that nature-based solutions may be one answer to mitigate climate change. So that is how we came to the blue carbon storage focus. And it was already mentioned in the HELCOM Ministerial Declaration of 2018, and also in the Baltic Sea Action Plan from 2021. It has its own part of the horizontal topic in climate change actions. So marine protection has thus received more attention as an essential component of climate protection. And as we heard in the morning from Sebastian Unger, only healthy and resilient marine ecosystems are valuable for the climate system, for example, as reliable carbon sinks. So next slide, please. Give a short background on the German HELCOM chairmanship. We had the focus, amongst others, on climate change and picked out also blue carbon as an emerging field of action, and brought this into discussions by having this workshop in November of 2021. Just hurry up to go to the contents. So next slide, please. Just to refer to the climate change fact sheet we heard before from Markus Meyer, I just wanted to point out some messages which were included there. So at first, the part on blue carbon storage capacity focuses only on the vegetated coastal ecosystems, which is one of the definitions for blue carbon, and it shows that these ecosystems are very susceptible to multiple aspects of climate change. And I think it's quite interesting that they also brought up the idea of a Baltic scale strategy on blue carbon as an option, or as they say it, as an yet untapped potential. So then in the next slide, we really go into the workshop insights. So Germany hosted the workshop together with HELCOM. We had the focus on the blue carbon potential and had the aim to harmonize the perception of the term blue carbon, which is not such specific, as we will see later on, and also to discuss scientific and political conditions for blue carbon in the Baltic Sea region. We had a quite lively exchange on this workshop with about 40 experts from the Baltic Sea region, and it does not only look at biologists or oceanographer, but also colleagues from marine and coastal peatland management. So we try to reconcile different areas of expertise and experiences. So we had very valuable input presentations on the role of blue forests or seagrass in particular. We had also presentations looking at the coastal carbon storage worldwide, but also looking over the marine realm, or besides the marine realm, we included assessments of the peatlands or paludiculture in coastal areas as nature-based options. And we had also input from a colleague on economic instruments to finance and implement coastal carbon sequestration to stimulate the discussions. So in the next slides, I'd like to give a quick insight into the contents itself for projects and initiatives. As I mentioned before, we had compiled several projects on blue carbon topics in the Baltic Sea area, and I'm sure that there are some more to be added this year. So we had projects on trace gas monitoring, but also carbon sequestration in special for coastal ecosystem. We had also mentioned carbon sink, missing carbon sinks. And what I like to highlight are two projects, which is Sea Store and Coast Clim. So the next slide, just give a glimpse on that. It's an ongoing project focusing on German waters, so Baltic and North Sea. And to us, it seems very well developed to detect the carbon storage capacity at different sites. And the next slide, I like to point on a very interesting initiative, which is the Transboundary Center for Coastal Ecosystem and Climate Change, in short, Coast Clim, which was founded by the Stockholm University and University of Helsinki, and those presented this initiatives, or they invited to be included in this kind of multidisciplinary partnership. So with the next slide, I like to go over to the barriers which were discussed for blue carbon habitats to develop. So one more theoretical barrier is the lack of consensus on the blue carbon definition or the perception of blue carbon. But more important, we think, are management or also competing land use at the sea, but also at the coastal areas for sure, like tourism dies. And if you think of some regions, you may also include agriculture, which affect coastal peatlands or salt marshes. We have much more listed here, like stakeholders, lack of funding or more support from missing support from stakeholders outside academia, lack of funding, but also lack of knowledge and knowledge transfer. So when we came in the workshop to the proposed solutions, which were which are on the next slide, summarized. We looked at the important implementation of the Baltic Sea Action Plan as a very central tool. We had also looked at the binding policies which promote the liability within these action plans. But we also discussed how to use or how to motivate policymakers. So maybe one option might be to point out the cost of inaction and the benefits of investing into blue carbon habitats. So as we heard, we know a lot of we have a very good scientific basis for the Baltic Sea, but there are a lot of much more questions. So we have also found that it would be important to have a kind of large-scale mapping for blue carbon, and also a kind of reprocessing of historical data. And I think what we are doing today, but will be important also as well in the future, is the improved communication with stakeholders, and also kind of information campaigns to bring in the topic to all the relevant stakeholders. So in summary, the next slide, we would say we have a kind of definition of the term blue carbon. You have it here on the slide on the right part, but it's also in the workshop report. We have this kind of definition not yet completed, but we see it as sufficient to work with. We have a lot of heard and seen a lot of projects and initiatives in the Baltic Sea region are ready to support the implementation and to bring in blue carbon habitats in the right in the mood no in the state them to support carbon sequestration. And we also had seen that they need to be locally examined and improved, but the transboundary and or regional cooperation will be very helpful in assisting this improvements. So focusing on or a very important point within the discussions was that even if we focus on the blue carbon or similar nature-based solutions, we should not see that as a kind of excuse to not reduce greenhouse gas emissions at source. So that will still be the first thing to do. From our point of view, we have also a short outlook for blue carbon, as already heard in the morning on the so next slide, please. As already heard in the morning from Sebastian Unger, there are several projects going on which address the carbon sequestration. For example, the Federal Ministry of the Environment promoted this kind of nature-based natural climate protection program, and but what you see in the upper corner, it's also a lot of research going on funded by the Ministry of Education and Research within Germany, and also within EU or other regional research networks. So I'd like to go over to the take-home messages. I think the most important you may take with you from my talk today is that nature-based climate mitigation is to be strengthened in the Baltic Sea region. And we think that implementing the Baltic Sea Action Plan will be one very important step. So we see that stakeholders from all relevant sectors are needed to increase the broader knowledge, but also to build up comprehensive protection of existing blue carbon habitats. And yeah, we want to give as outlook or as one sign of our contribution that Germany has taken up the issue of blue carbon during its HELCOM chairmanship and will continue to support the development of these kind of sustainable measures for conservation and renaturation of marine and coastal carbon binding habitats. So the German National Action Program will promote these kind of nature-based solutions as well, yeah, next to others, as Sebastian Unger already said. So we like to initiate your thoughts. What will be your contribution for having a healthy and resilient Baltic Sea with blue carbon habitats? So I like to thank you for your attention, and also the HELCOM Secretary for the support of the workshop in 2021, as well as for the stakeholder conference today. Thank you.
Thank you very much, Ms. Karkawa. We will now get some time to digest all of the information that we've received so far, and we will have a 10-minute break and be back at 15:35 or 14:35, depending on what time zone you are in. So please go and grab a cup of coffee and get yourself ready for the second part of today's event, where we will hear the keynote for the stakeholder conference and also jump into the panel discussion. So thank you, everyone. See you back here at 15:35 or 14:35, depending on your time zone. Okay, welcome back, everyone. I hope you had a nice coffee break. We will now be moving on to today's keynote speaker. And today's keynote speaker is Mr. Erik Källström from the Swedish Meteorological and Hydrological Institute, or SMHI, who will be talking about climate projections for the Baltic Sea region. So where are we going from here and what might it mean? Erik, please go ahead.
Thank you very much, and thanks for the invitation to speak here. I will just share my screen and make sure it works before I start talking too much. So now I pressed share. I hope it works from your side. Is that okay?
Yes, we see in presentation mode. Thank you.
Thank you very much. Okay, thanks. So I will talk about the climate change projections for the Baltic Sea region, and this is of course talking about future, which is very uncertain. So I will just very briefly start here by looking at this picture. We don't really know about the future. These are scenarios for changing forcing conditions in the future. This is primarily related to how CO2, the carbon dioxide concentrations will change in the future, but also other greenhouse gases and other factors influencing the climate as well. And as you can see, there is a whole range of very, very many different scenarios in this one, and they are kind of grouped in here 4 different main paths into the future. And you're probably quite well aware about this, and but these are the so-called representative concentration pathways that we are looking at here. And to the left, there is a scale of net CO2 emissions from now and into the future. And I say now, but this picture is actually a few years old. We are slightly higher than we were at that point. But you can see here already now that there are scenarios all over the place, both these increasing very, very strongly, so very much larger increases and emissions in the future, and also others with more leveling off, and also yet others with decreasing concentrations, and even talking here about CO2 removal, the blue scenarios there at the bottom. So they are a very, very wide range, and that's also one of the main uncertainties for the future. So that was about the forcing conditions. So this is the first thing we need to keep track of when we are talking about the future and future climate change. What climate models tell us when we look at the scenarios driven by such emissions is that we know that we are going to see a continuous climate change into the future, as emissions are very high. And even if we end up on one of the pathways with slightly decreasing emissions in the future, or even largely decreasing emissions, it will take some time. And before that, we will still increase the amount of carbon in the atmosphere, and therefore the atmosphere and the climate system will warm. And here are horizontal or two-dimensional patterns of near-surface temperature change at some different levels of global warming compared to pre-industrial conditions. And these are 1.5 degrees above pre-industrial conditions at the left, 2 degrees in the middle, and 4 degrees to the right. And you know, we have the Paris Treaty, and there we try to then stay at most at 2 degree warming, but preferably less than that. But we should then recall from the previous picture that those scenarios that leads to such pathways, they include a lot of carbon dioxide removal from the atmosphere, and that so that is highly uncertain. If you just quickly look at the patterns here, we can see that the most reddish colors, they are found close to the Arctic in the north, and that's part of actually the Baltic Sea area, especially the northern areas. And these are areas where snow and ice are projected to decrease more than they have already done. And that has a very strong so-called feedback and amplification impact on the climate change. So once you get slightly warmer conditions, there is less snow and sea ice on the ground and on the ocean. And that leads to more of the incoming solar radiation being absorbed, heating the system even more, and thereby amplifying the warming in the region. There are a couple of other feedback mechanisms too, but we can say that's the main thing. So the patterns here are quite strong, and they are also similar for these different regions over the time. It's not just temperature increasing, but this temperature increase, it leads to an amplification of the so-called hydrological cycle. That is the recycling of water through the system. And a warmer atmosphere means that it can hold more water vapor. This is a physical property of air. So the warmer it is, the more water vapor it can hold. And thereby, warmer air being advected over an open ocean surface somewhere, or over land for that matter, it can take up more water through evaporation from the surface. And that means more water into the atmosphere, and then that water needs to precipitate out somewhere. So there will be also more precipitation. But at the same time, this actually also implies that there is an increased risk for drought and dry conditions. As this evaporation goes on, at some point the ground is really dry, and then it can continue to even evaporate even more. So there is also risk for really dry conditions whenever there is no or very little precipitation. So what this tells us is that there is an intensification of the hydrological cycle, but also there will become larger variability in precipitation and differences between what can be considered wet and dry conditions. The map to the right shows now more focused on the northern hemisphere, and then this is now changes in maximum 5-day precipitation. And you can see greenish colors over parts of the Baltic Sea region here, indicating increasing 5-day precipitation. You can also see a lot of hatched regions here all over the northern hemisphere, and this indicates where models don't really agree upon the strength of these changes, increases or decreases, and not to what extent. So now let's look into some more details here, and I will first just very quickly tell you a couple of words about climate models. And these are 3 maps here showing different tentative resolutions, horizontal resolutions of such models. From the left, at the quite coarse scale, at more than 200 kilometers size of these grid boxes, if we call them that, as you can see on the map there. To the right, we have a very much higher resolution. It's down to 12-kilometer resolution. And of course, it's quite obvious. You can see here that the land-sea mask, the difference between land and ocean, are quite different. It's much more realistic to the right compared to the left. But also we can see that the height of the ground, which is indicated by the colors, it's also much more realistic to the right, where the mountains, the Scandinavian mountain chain, for instance, is much higher compared to in a coarse scale model indicated by that on the left-hand side. So land sea mask and also topography conditions are much better determined at higher horizontal resolution in the climate model. And this is important for simulating impacts and also how changes will be at different places, and also impacts of mountain chains, for instance, are quite different in such models. But it's not just the land sea mask and mountains, but it's also how to resolve the processes that are interesting. Now this satellite picture you can see in the middle, it includes some frontal system, a low pressure system up in the north, and then there are various kinds of clouds, etc. And you can immediately understand that the model with the resolution as the one to the right is much better at depicting and simulating processes like the frontal system here over Scandinavia, compared to a core scale model like that to the left. And what you saw before, the other maps I showed, they were from global climate models, and they are generally run at quite coarse resolution. This is more like the map to the left. So they don't really capture all of the details, and thereby they are maybe not the most suited ones for looking at regional changes at the local scale or regional scale, like in the Baltic Sea region. And how to do this? We often use something we call regional climate models, and that's what I'm going to take the results from that I show you in a couple of minutes here. And what we do there is that we use a global model covering, of course, the whole globe, but then we downscale it with something we call a regional model, just representing a certain area of the world here, Europe, as you can see here. And this is exactly what's been done here. And the results I will show you now, most of them will be at this very high resolution to the right, 12.5 kilometer resolution for all of Europe. We have run such models very many different times. I will not go through this in any detail, but I will just tell you that what we are looking at here are results from something we called EuroCordex, where Cordex stands for Coordinated Regional Downscaling Experiment. And this has been done for all continents over the world. And here we take a look at the European branch, and the very big matrix to the right there indicates that we have run a large number of global models. These are the horizontal lines, and then we have used different regional models. These are the vertical lines here, and all of these green and yellow boxes are boxes or simulations that we have really done in a large European effort here to simulate the climate change in the future. And we have also applied it for different emission scenarios. And now we get back to what I showed in the first figure, from very low emissions to very high emissions. So we have simulated different conditions here in order to say something about future change under different forcing conditions. I will also say here at this point already that there exists a lot of different data and things that can be analyzed and used for different types of studies for the Baltic Sea region and for other parts of Europe, and also for further impact studies as well. Now some results from this large ensemble of data, and I will give the reference at the end. There is one paper that I picked most of the pictures from in this talk, and it's by Ole Christensen and co-workers, and Ole works at the Danish Met Office in Denmark. So this now shows seasonal mean changes in here temperature, and in the upper row we can look at winter conditions, and in the lower row we can look at summer conditions. And there are 3 maps on each row, and in the middle you can see a median, and median here means among the different models that we are looking at. So this is the median response, and then we also look at 25th and the 75th percentile. So this is the 1/4 of the models that are on the colder side to the left, and the 1/4 of the warmer models. This is the number shown on the right hand side here. And what can we see here? Well, we see, of course, there is strong warming. So all the colors here are orange or reddish, and that indicates warming. And this is now at the high-end scenario at the end of the century. So there are very large numbers actually. I can also tell you that the patterns look very similar in other scenarios with the lower forcing, but then of course with lower numbers of forcing as well, and now with temperature change. And I will get back to that in a minute too. We can see that the warming is larger in winter. This is the upper row compared to summer. And this is a little bit, again, reflecting what I talked about before with these feedback and amplification effects from snow and sea ice, which is really strongest in the winter half of the year. What we can also see is that there are differences between the left and the right-hand side here. So there is even if we have the same forcing scenario, there are also some uncertainties, and models give slightly different results. But the overall picture here is very robust. There will be more warming in the future. We can look at different things here, and this is just one example. This is from an older set of models, but it's just to illustrate something here, where we look at wintertime conditions, and this is now for December, January, February, and we picked out data from a model from an area close to Stockholm, where we look at to the right here at the upper probability distribution. This is now every day in a 30-year time period. We have taken the average temperature of that day, and we compile a frequency diagram of that. So to the left you can see very cold temperatures, cold days, and to the right you can see the warmer days. And you can see here typically that in such an area where we have some icy conditions, there are quite a number of days with temperatures close to 0 degrees. There are a few warmer days, and then there is a long tail to the left here with really cold conditions. So in the past, we are used to having high pressure situations and really cold air masses in the winter at some points, not every year, but quite often. In the future here, under this scenario, there is a very strong shift in this probability distribution, and you can see here that it really shifts towards the right. It also gets a bit more narrow. So many of these very, very cold days in the tail here in the uppermost panel, they are completely disappeared in the lower one. So this also gets back to what I've talked about now already 2 times about the snow conditions in winter. When there is no more snow in the very warm future, there is not the same possibility for the atmosphere to create really cold air masses, and this is what's been reflected here in this view graph. So this graph actually shows us that in terms of temperature climate in winter, there will be less variability, and there will also be less cold extremes in the future compared to the previous climate. To the left, I'm sorry, this is now in Swedish, I should have translated. This is the number of really cold days with low temperatures, and this is just for Sweden to show what it looks like in one simulation here to the left, with quite many such days in the north, and then in the future we see this very strong decrease in such days at 2 degrees global warming. So this just indicates that very cold days get much more unusual in the future. We'll look quickly now into precipitation also, same thing as before. So now these are winter and summer conditions. There is our green colors here indicating increased precipitation in the north or in the winter everywhere, and also in summer in the north you can see green colors, while in the south there is a difference between the driest models. They indicate even less precipitation here to the left, while the wettest ones indicates more precipitation. So there is a clear uncertainty here in the south whether we will have more or less precipitation in the future. Now these can all be projected in scatter plots like this. I will show a few, so I will explain this a little bit. This now shows the temperature change, the horizontal axis here, and while the other axis shows the changes in precipitation in percent. And to the left, we have changes in the winter, and to the right, changes in the summer. And this is for the whole Baltic Sea area, actually, all grid points we have. And then we can see that different scenarios, from the blue with lower emissions, to the pink one with higher emissions, to the red ones with very high emissions, show increasing temperature change. And these are now for different models that we have been looking at. And there is some spread, of course, so there is some uncertainty, as I talked about, but there is a very clear warming signal as time goes by here. And you can also see in this case there is a wettening trend with more precipitation in all of these models. In summer, it's more unclear what will have happen with precipitation on the whole area. As we saw before, there were both changes in the north, increases and decreases in the south. And this is illustrated here now. So this is just summer. To the left, we have in the northern part of the Baltic Sea region with slight increase of precipitation in most scenarios, while to the right, we can see decreases in quite many of the simulations that we have been looking at. So this is average precipitation for the whole season. And now I will very quickly just look at daily precipitation to see how intense precipitation might change. So remember this picture now with summer conditions in the north and in the south. And here we now look at the most intense days instead. So these are now days with very intense precipitation. So these are 10-year return periods. So the strongest rain you can think about in a 10-year period, how that changes instead. And here we see increases both in the north and in the south, even if there was a tendency for decreasing seasonal mean precipitation. So that means that intense and extreme precipitation might increase even in these areas. Quickly looking at some other features, these are wind speed changes, and even if there are some sloping lines here, there is also a very, very big scatter of the points. So both in winter, there is a weak tendency for some increase, and in summer, a weak tendency for some decrease in these simulations. But the tendencies are weak, as I say, and there is a large uncertainty. So here we can't really say anything about any significant changes in wind speed into the future. What is really clear, though, is that changes in snow, and this is indicated here. So these are all land areas in the north to the left and in the south to the right. And we can see a very strong decrease with time here. The stronger the emission scenarios, the red points here, the larger decrease in the snow cover or snow amount we will see into the future. So I will wrap up here, but first I will just show something how this could possibly impact hydrological conditions. And the example here is only for Sweden, but many of the features here are quite general in the area, and you can think about it in a larger perspective. So this is my second last slide, and then I will conclude. So here we can see how these simulations, what they produce in terms of hydrological response if we run them through a hydrological model. And in the middle here, you can see the average discharge in such a model. So this looks at average river flow, basically, in different rivers. And there is a slight tendency for increasing slightly bluish colors here in the northern half of Sweden, while the changes are very small or modest in the south. And if we look at high floods or 10-year flood events, these are really strong floods when there is a lot of water in the rivers. We can see, again, increases in quite large parts of the country. But at the same time, we see reddish colors up here. So these are areas where there is less snow and less snow melt, and thereby the spring flood is actually decreased in the scenarios. While in other areas, we can see stronger rain-driven events, basically. And to the left, we see instead the numbers of days with low discharge. And this indicates then especially dry conditions in summer. And now we see decreases of such days in the north, again indicating more and more precipitation and also higher river floods or less days with really low discharge. But in the south, there is an increasing risk for days with low discharge. So we see also this, as I talked about before, larger differences between wet and dry, actually. This is something that shows up quite clearly. So the final picture, just to conclude, and I've already said this, that we look at continued warming in the whole region. We see a change and a shift in the seasons. The winters get shorter, milder, and there is often more melting episodes, etc., while summers gets much longer, and If we also add to this the precipitation, there is more precipitation in general, but in summer we can also have really dry summers with little precipitation. And even if there is precipitation in summer, the higher temperatures will lead to more evaporation. So that can also drive large differences between dry and wet conditions in the area. I've also talked about more intense and heavy precipitation extremes. The less than snow and ice, of course, is very important, and the uncertainties in the changes in wind speed. And here is a reference then to the paper that I've talked about sometimes here as well. So thank you very much.
Thank you, Erik. That was very informative. And now we will pick up on all of this, because now we have some indication of where we might be heading. And now we will talk about what we can do about it and what is the role of the region, the Baltic Sea region, in this work. So we will move on to the panelist discussion. And I can first answer one of the questions that we've gotten through the Q&A, which is whether or not the recording will be made available to the public. And yes, it will. It will be put on the conference website. Once this is concluded, there will also be a short and snappy outcome from today's event, mainly relating to the presentations and the discussions that we're going to have now. For the panel, we've tried to represent different parts of the Baltic Sea society, so that we can have the viewpoints of the viewpoints represented of different aspects of who is affected by climate change and in what way around the Baltic. And again, here it's really quite important that you, as stakeholders taking part in this event, you are, so to say, 280 people last panelist on this panel. It's from you that we want to hear what are your concerns and what are your views on our relationship with climate change and the environment, and also where we should be going next. So the panel consists of representatives from civil society, here represented by Johanna Kjellén Fox, who is the director of the WWF Baltic Ecoregion Program. Then we have the scientific community, who is represented by Marcus Meyer, who was already introduced as part of his presentation on the BEAR reports and the climate change fact sheet. Then we have Rüdiger Strempel, who represents the policy aspect and the international cooperation, and is the executive secretary of HELCOM. We have Henna Rinne, who is a senior specialist at the Ministry of the Environment of Finland, and she represents national policy and national implementation. And then last but not least, we have Evija Schmide, who is the chair of HELCOM, the Deputy Director General and the Director of Fisheries Control Department at the State Environmental Services of Latvia. And she represents both the national and the international policy perspective. So she kind of functions as translation between the national and the international perspective. Now, we know that we have all of these global agreements, Paris agreements, and a lot of more recent international commitments that pick up on climate change, even when they are not directly climate change or more directly focusing on climate change. For example, the EU biodiversity strategy, the EU Green Deal, the upcoming new global targets for biodiversity, and so on. So there is clearly an interest on the global level to tackle this global challenge. Then on the national level, there are a lot of national initiatives to actually directly deal with the implications of climate change. These can be mitigation measures, but also a lot of adaptation measures. In the Southern Baltic, for example, there is a lot of high need to address sea level rise, but not just the average rise, but the effect that it's having on the coastline and so on. But the question is, as a regional body, what can HELCOM do, and where should HELCOM position itself in relation to these global and national commitments that are already ongoing? Is there any value in having this kind of regional perspective for climate change, or does it more add to a kitchen where there are already too many cooks? So this is something that we would like to bring up in today's panel discussion, and also use this to help guide HELCOM's climate work in the future, because the idea is, of course, that any work that we do should contribute to and add value to already ongoing efforts. And climate change is a new topic within HELCOM. We've only started with the climate change fact sheet, and they now have these actions in the Baltic Sea Action Plan, but there needs to be some concrete kind of guidance on where should we go from here. So with that, I would like to open to the panel and ask them to, in very brief words, address this question. Is there a role for the regional perspective in climate change? And if so, what do you think it is? And we will start with Johanna, who will present civil society perspectives on this. Thank you.
Thank you, Jannica, and hello, everyone. Good afternoon. Well, we definitely, from WWF side, we see that there is a regional role to handle climate change. And I mean, the Baltic Sea and the water in its catchments sees no boundaries. So in order to create healthy ecosystems that are resilient to climate change, we have a responsibility, and we need to work collaboratively across the region. We heard today that maybe we need a strategy for blue carbon. That could be something, a role for the HELCOM community to work towards, as well as if this region will see a lot of impact from climate change. The less we do on the mitigation front, the more we have to do on the adaptation. And here the region can push global policies, EU policies, to actually work more on the mitigation rather than just have to deal with adaptation later on. Thank you.
Thank you very much. Then we would open up for the opening statement by Marcus on this. Is there a regional perspective, and if so, what is it? Marcus, please.
Thank you, Jannica. The Baltic Sea region is rather specific in many respects. So with the Earth system is different than other parts of the globe. And there are many stressors acting on the Baltic Sea ecosystem, but also on the system on land and on the anthroposphere, which is actually different in other parts of the world. So we have definitely a very specific setting. And HELCOM traditionally works with the setting of the environmental status of the Baltic Sea. And as the climate change is interacting with all the other stressors, of course, it has a very big role, and that can only be tackled in combination. So I think, therefore, there is an added value of the regional perspective. So in climate adaptation and mitigation, but other are marine spatial planning, marine protected areas where climate refugees have been discussed in addition. And the most prominent example is maybe the traditional nutrient load abatement strategies within the Baltic Sea action plans. A plan that has been calculated without any effect of climate change, but need now to take into account climate change. So larger reductions are needed. So all this together makes it really necessary to take climate change also in the region into account and to put an emphasis on that. Thank you.
Thank you, Marcus. Then I would invite Henna to present her views on this.
Thank you. Thanks for this opportunity to present some thoughts on the HELCOM work on climate change. I think the main added value from the work that HELCOM is doing related to climate change is simply that it brings the focus to the Baltic Sea. That how will the Baltic Sea affect it, and how can we best mitigate these effects? So I see added value already in the HELCOM climate change fact sheet that kind of concisely sets the scene, or kind of the baseline for the work that we need to do, and shows that it's not just the physical chemical parameters, but the whole ecosystem and also different human uses that will be affected. So with climate change, is obviously the reduction of greenhouse gases that is the most important thing, but it's true that HELCOM as a sort of regional sea convention is not the forum where these climate mitigation targets are set, as we have the global targets and we have the EU targets, and all countries have their national programs. For example, in Finland, we have a target of being carbon neutral by 35. But what we find especially important is that solving climate change, biodiversity loss, and pollution as a sort of an entity. So going towards carbon neutrality, we cannot forget biodiversity or increased pollution. And I think identifying these linkages is essential also in the Baltic Sea protection. And I think in the Baltic Sea Action Plan, this thinking is already kind of nicely included. And I definitely see added value working with these issues further also in the future within HELCOM. And I also want to mention that increasing climate resilience of the ecosystem is very important when talking about climate change. So with efforts that HELCOM is doing to improve the state of the Baltic Sea, we also improve the resilience of the ecosystem, which is really important, as the climate change will bring more stresses to the species. But as climate change is already clearly seen in the Baltic Sea, as we have seen today, it's self-evident that the climate scenarios need to be incorporated into HELCOM work at many different levels in the future, especially when talking about mitigation of eutrophication, but also, for example, when planning new marine protected areas or effects of extreme weather events on shipping, for example. But this is not easy, and especially when there are so many uncertainties, as we have seen today. We don't know how the climate's going to change, but we're even more uncertain when we go like to their ecosystem effects, for example, food webs. So we definitely need more science, but we also need to take action already on what we know. So I'm happy that we have HELCOM as a sort of a regional forum to discuss and work on these issues further together. Thanks.
Thank you, Anna. Then I would like to invite Evia to give her perspective on this.
Good afternoon, everyone. Yes, I think the regional cooperation is very crucial and absolutely necessary. And then here I would like to rephrase all known sayings that think globally, act locally, to think globally, act regionally. As we know, we have the very comprehensive Baltic Sea Action Plan, which includes also specific actions addressed to the climate change. And so we, at regional level, we can detect specific problems and find solutions to them. And in the framework of HELCOM, there has been successful regional cooperation nearly 50 years. And while the current political situation does not facilitate that cooperation at full scale as it used to be before Russia's attack to Ukraine, that one of the main priorities of the Latvian chairmanship in HELCOM is maintenance of HELCOM as an effective and well-functioning organization of regional cooperation, which is capable of action, including even in foreseen and in force majeure situations as it's now. So I see it was really a big hope to HELCOM as a regional cooperation platform also in future. Thank you.
Thank you, Evia. And on that note, I would like to ask Rüdiger, as Executive Secretary of HELCOM, to bring his perspective on what HELCOM's role would be in relation to climate change, and not just HELCOM's, but also in general, this kind of regional perspective to climate change. Rüdiger, please.
Can you hear me now? I again have
Quite
an echo,
a
but I
lot of
hope you can
echo.
hear me well. So thank you very much and good afternoon once again. Yes, I do believe that regional cooperation can offer a considerable added value. And I have to say that I'm generally a great believer in regional cooperation. If I weren't, I probably wouldn't be doing the job I'm doing now. And to basically pick up on something that was said by several previous speakers, this of course especially applies to marine areas where we have no boundaries and we need to work cooperatively to address our issues, and also to an area which is as specific and where the conditions are as specific as in the Baltic Sea. There's a reason why we have 4 levels of policymaking. We have the local, national, regional, and global, all of which are needed. And there are some things that can be done at, or need to be done at all those levels. And there are some things that can and need to be done only at certain levels. And the beauty of regional cooperation is that it's more targeted than global and far less limited than national or local. And that's exactly the level at which we need to work, because it takes account of natural, but also political, institutional, and economic, and even societal situations and interlinkages and developments in the region, which we have to do if we want to adequately address the issues we're faced within our region. And luckily, the Baltic Sea region, of course, is a region which has traditionally cooperated. And I'm not just talking about HELCOM now. It's a region where cooperation and interaction goes back far longer than just HELCOM, centuries, if you like. And that is something we can pick up on. That's something we can build on. And in doing that, we're promoting synergies, and we're coordinating and we're sharing burdens. And this in turn avoids duplication of efforts and leads to a more effective response to not just climate change, but issues we're faced with in general. And of course, also climate change. So the answer is yes, I think it offers considerable added value.
Thank you, Rüdiger. We'll now start taking in questions also from the audience, and we will start with a quite complex one to put all of the panelists on their toes here. So we have a question that has come in that relates to timescales, and here it's the timescale of climate change, but also the timescale on the work that we're doing regionally and under HELCOM. So impacts of climate change are documented to come faster than might have originally been expected, but implementation of measures is quite slow. This includes, of course, also the Baltic Sea Action Plan. And the recovery of ecosystems is even slower and might be further delayed, either due to insufficient measures where we might not be aware that the measures that we're putting into place aren't doing enough until we can see that kind of reaction in the environment. And on top of that, there might be delayed because climate change mitigation measures might actually be counteracting some of the measures that the Baltic Sea Action Plan is putting in place, or that we are in general taking in the Baltic Sea environment. This could be, for example, the increase in offshore wind power, which is expected to have an impact on biodiversity. Overall, this results in potentially losing natural Baltic Sea carbon storage capacity faster than we can actually act to try to prevent that. Now, this, of course, really well illustrates the complexity of climate change in relation to our needs as a society, but also, and more directly, the needs of the environment to increase resilience and leave enough space for nature to do the job that we need nature to do in order to mitigate climate change. So would you have in the panel any reflections on how do we best approach this? Is there something that we can do on a regional level to try to kind of minimize this need for trade-off? And if so, what would it be? And I would ask the panelists to raise their hands so that I can see it. Yes, thank you. Johanna first.
Thank you, Jannica. And yeah, like you said, a complex question. I think from one side, it's important to dare to act. We know a lot. We have heard a lot of the science today. And even if there are uncertainties, we know that climate change is going to affect this region. We also have a Baltic Sea Action Plan that, if implemented fully, can be a very good step towards combating the impacts on this region. And we have to act. We cannot no longer just wait for more science, and we need to assess how and if we do this correctly and what way and what not. We need to act on the knowledge we have now and invest in protection, in nature restorations, in actions that we do know will increase the resilience of our ecosystems, and not waiting for the perfect science, because I don't think we're going to have that. So that's from something I would strongly put forward in this debate, is to dare to act.
Thank you, Johanna. Then Marcus, please.
I agree completely that action is already now needed. It is definitely so that we are not knowing anything, right? I mean, the uncertainties about the projection is very large, but we know that there is an increase. We know that with the settings given, the water temperature will increase by the end of the century by 1 to 3 degrees. The sea level will rise, the sea ice will vanish, and so on. So there is still some information that we can already now use for implementing into the marine management. Then concerning the question in the chat, it was about the timescale. There's actually indeed a problem in the timescale of the management, the reaction, but also in the system itself. And it is difficult to say if climate change or the ecosystem is slower. It is definitely the ecosystem and the climate change has a very long time scale, but also fluctuating time scales, like multi-decadal variability that might overshadow general trends in the back, but might cause quite warm decades right now. But I think all this that we cannot really predict, because it's the noise in the climate system, does not in any case affect, should affect the management options here, because the projections in many perspectives show a clear warmer future and what might happen. So we should not look at this uncertainty and too much. Thank you.
Thank you, Marcus. Then Rüdiger, please.
Yes, thank you very much. So I agree with what was said. I mean, I know that international organizations, and HELCOM is no exception in that regard, are generally accused of being very sluggish. And in point of fact, sometimes they are, sometimes they aren't all that sluggish, but be that as it may, I think the point is that indeed we have no time to lose. So, and especially knowing that processes in international organizations can sometimes take a bit longer than we might wish, we have even less time to lose. So we have to work, and we have to continue our work now. And as the two previous speakers already pointed out, we have a lot of knowledge already. We don't know everything, and we certainly don't know enough, but we have a lot of knowledge already, and we can act on that. And simultaneously, I think what's really important, though, is to increase our knowledge, to work on actually learning more, some of which will probably, some of those learnings will be derived from what we do. And we may get some things wrong, but the worst thing we can do, and the way to really get it wrong, is by not acting at all.
Thank you. Then Henna, please.
Yes, thank you. Yeah, I guess with the climate change mitigation, one might say that we are rather late, as we have known the problem for decades, and as a whole human society, we are kind of now on the crisis stage, and we really have to act quick. But I would say that many of the countries and for example EU and the whole global society has now kind of good goals, at least, or good targets, and rather quick targets also to do the actions that need to be done for the climate change. But related to the Baltic Sea and the effects on the Baltic Sea, I think it's not that we are starting now. Like, the HELCOM work has been ongoing for a long time, as it's been mentioned today, and also the previous Baltic Sea Action Plan was in place, and at least nationally we're now like implementing the Baltic Sea as part of the work that we are doing for the Water Framework Directive and the Marine Framework Directive and going on with the work. So we are definitely, there are gaps of knowledge as people have mentioned, but we know a lot and we know how to go forward. And we have these good guidelines from the Baltic Sea Action Plan and the national programs as well. Thank you.
Thank you. I think this touches on one of the other questions that we have gotten. You've now concluded that yes, we should take action, but we have a question that has come in from Niels Höglund from CCB, although under alias in the case of the chat. That is like, okay, we have to act on this limited knowledge already now, but how do we actually concretely do that? How do we stop this process from becoming stuck on the constant need for more information and discussion rather than kind of going ahead and implementing measures? What is this? What's the reason behind this barrier to taking action and this constant need for more information? And is there a way to circumvent it when it comes to climate change in a way that maybe we have not managed to do in the past? I've now paraphrased this question a little bit, but that would be my next question to the panel. So how do we need to take action, but how do we do that concretely? How do we get around the fact that we don't have the knowledge that might be needed and take action anyway? Are we talking about an extremely precautionary approach? And if so, then how do we politically get past this this barrier? Because this is, of course, difficult. There are many activities in the Baltic Sea that occur and use the same area, and climate change mitigation might be in contradiction with some of these, as also stated in the previous question with relation to wind power. So do we have any views or comments in relation to this from the panel? Yes, Johanna, please.
Thank you. I think one of the important parts here was actually brought up by earlier today. We're looking at the costs of inaction. What are the costs there? What do we stand to lose if we don't act? But then in general, we hear this is a stakeholder conference. I think all of us here have we have a way, we must make our voices heard as well to push for the climate and to act towards it when it comes to mitigating climate, to ensure climate adaptation also in a regional perspective, that becomes higher on the political agenda, even in today's day and age, and see how we can find win-win solutions in combating climate, in ensuring healthier, more nature positive future, as we say in the WWF, as well as developments such as offshore wind in the area. So in essence, basically, it needs to come up higher on the political agenda. That's what I would say. Thank you.
Thank you. Then Rüdiger, please.
Thank you. Yes, I would agree with that. And also, I think in addition to this coming up higher on the political agenda, it has to stay high on the political agenda, because I think we see this going in waves. Sometimes there's a huge focus on this particular issue, and then of course it takes a back seat to other issues. And at the moment, of course, we have a geopolitical situation which puts us, which on the one hand creates an opportunity to actually enhance and progress renewable energies, and on the other hand tends to maybe force us, or to feel we're forced to put them on the back burner. But this is just one instance. The point is that it has to stay high on the agenda, and it has to consistently remain on the agenda. Having said that, I mean, the question was sort of how can we overcome the inertia, or how can we overcome our tendency not to do anything? And of course, now this is something I have to say, but I also believe it. It's not like we're not doing anything. If you look at what's going on within HELCOM, we do have activities and we do have a certain matrix for moving this forward. So we have the Baltic Sea Action Plan, which has specific actions related to climate change. We have, as I said earlier, also during my opening words, the Baltic Sea Action Plan as a whole, insofar as it increases the resilience of the Baltic Sea ecosystem, also, of course, contributes to adaptation, not to mitigation, but to adaptation in the region. So we have a matrix, we are doing something, we have a plan to do more, but I think we still need to do even more, and we may need to do it far more quickly. And I think thus far, we've always seen that no matter what we did, climate change was faster. And we tend to actually, for a long time, I think we tried to ignore that. But the fact of the matter is that what we're seeing now surpasses the most pessimistic predictions of experts of only a few years ago. And I think that's something we have to bear in mind. And therefore, we have to stay active. We have to do what we're doing. And I guess in doing that, we really should not be daunted by our own courage.
Thank you, Rüdiger. Henna, please.
Yes, thank you. I must say that I don't completely maybe agree with that we are not acting as Rüdiger mentioned, since we have a lot of knowledge on the big agendas, both for the climate and both as well as for the Baltic Sea. So we know the big picture and we know what we should be doing, and we are actually doing it. So what is lacking on the knowledge side is a lot of well, of course, the climate scenarios, as we saw, there's a lot of uncertainty in them, and on the ecosystem effects of climate change. So what kind of ecosystem we will have in the future. So there is definitely need for more knowledge there. But for example, in the Baltic Sea, the most important thing is now the eutrophication mitigation, that we will improve the conditions for the and increase the resilience of the ecosystem at this stage. So I think that is the most important thing we can do in the Baltic Sea at the moment, and we are in the process of doing that. So in that sense, I think we have both knowledge and action. Thank you.
Thank you. Then Evia, please, and then Marcus.
Yes, thank you. Well, it was a great interest. I listened to the presentations from scientists this morning, and I had an idea that I think we need more to disseminate this information to public and society, and to make them more aware of this climate change, this problem, because of it's not just a topic of global organizations. It affects each of us, and all these hot summers. What we also experienced this summer, and also this species from south, which get more and more introduced in these northern regions, they affects each other, each of us, and all this in public and in society. And I think we need, we do already, but maybe even in future do more to get this problem to everyone, and to get more this understanding. And also they have also this support, maybe also from this politicians' sides, because we are electors and so on. I think the more information from society and gets the scientific information to everyone, us. Thank you.
Thank you. Then Marcus, please.
As a scientist, I would like to emphasize the role of assessments. I mean, that is the basis of all the political action in my mind, and I think here it is very important to get on with that, and to get stuck in assessments, I think, is the wrong expression. The knowledge is increasing all the time from science side, and therefore it's very important that this will be regularly updated, and I think that is the plan. So the bears will be updated regularly, and also the climate change fact sheet. And in my mind, however politicians react, they should look at these assessments and the latest information that is available. And I think if that is then really done, then the best management can be in place. Thank you.
Thank you, Marcus. Then Johanna.
Thank you. Something I would like to add as well is to really look at this holistically, regardless of what actions we do to reduce the impact on our Baltic Sea. We also have to think of how do we do this in the light of climate change. Everything from when we decide on fishing quotas in the Baltic, or when we reduce nutrient reduction, or all of that has to be done simultaneously as we also reduce the impact of climate change. When we plan protected areas, how are these in line with ensuring blue carbon? When we plan offshore wind parks, how do we ensure that this is not done on the sort of at the expense of biodiversity in the Baltic Sea? So this is really something we would like to stress, is to do this holistically. Similarly, where our finance in the Baltic economy, where is it going at the moment? And a little bit of a teaser, but WWF will be releasing a report in sort of early next year that looks at, we still have a lot of finance moving towards oil and gas exploration. Now that we can't have in a future where we have to combat climate change. Climate change is already here. We need to sort of move away from investing in activities that aren't helping us when it comes to climate change. Thank you.
Thank you very much. Rüdiger, please.
Thank you. I'd just like to briefly pick up on what Johanna just said. Of course, the holistic aspect is extremely important, but in that regard, I'd like to point to the Baltic Sea Action Plan, which actually then does not have a specific climate change segment, but actually includes climate change in the horizontal topics segment, which is not because it's unimportant and doesn't deserve a segment of its own, but specifically because it is an overarching topic, and it touches on every one of the other topics included in the thematic segments. And so this is acknowledged and this is recognized. And now, of course, we have to put our money where our mouth is, and we have to do this. But I think the Baltic Sea Action Plan in that regard actually offers a good way forward and shows that this facet of climate change is acknowledged. Thank you.
Thank you. Then I would like to combine two of the questions that we've gotten in that deals with the regional cooperation kind of functioning as an umbrella. And one is the question that, is there some kind of exchange of best practices with regards to climate change adaptation and mitigation on the regional level already now? And the second one deals with what Johanna kind of touched on here with the financing, that are there any international, national, or I guess regional support mechanisms for businesses that you are aware of that would directly contribute to the reduction of carbon and nutrients into the Baltic Sea? So essentially, are there tools to speed up and leverage this action that we have already concluded that we need to take? Do we have any comments on these from the panelists? No? Yeah, okay. Johanna, please.
Thank you. I can answer a little bit on the finance part. I wouldn't say it's regional, but for any financial institution and for when investing in any activity, from WWF side, we see that one should be using the UN's guidelines on how to invest for a sustainable blue economy. So that is for banks, for lenders, for any financial actor to be using, but that is not specific for the Baltic Sea region. Yeah, thank you.
Thank you. But as the question also referred to other international support mechanisms, then at least it does qualify for the international bit of it. Rüdiger, please.
Yes, thank you very much. I'd just like to briefly touch on the issue of exchange of best practices. We always have to bear in mind, of course, that HELCOM is not operating in a vacuum. So on the one hand, we're very closely linked, of course, to activities within the European Union, and therefore there is an exchange, of course, there, and that reaches beyond just the Baltic Sea, because the European Union happily reaches far beyond the Baltic Sea. And secondly, we also cooperate, of course, with other regional seas conventions and with other international processes generally across the UN and globally. So there is a constant exchange to a greater or lesser extent, also with other conventions, with other mechanisms, other processes. So this is, of course, taking place, yes.
Thank you. I would like to pick up on that, looking at where we're heading in the future, and ask whether the panel feels like there would be a need for more exchange on best practices in the Baltic Sea region. We have now seen that it does provide some very valuable insights in the scientific community, where Baltic Earth already is a forum for exchanging best practices and information, data and results, and also to kind of compile knowledge across the region. But this could this kind of format be used also for other areas? For example, when it comes to what actual mitigation measures are the countries using, or how are they approaching things like financial incentives and regulating financial incentives and so on. Is this something that HELCOM could function as a platform for in the future? I would open this for the panel and ask if you think that this is something, a concrete way that HELCOM could support the countries in their mitigation and adaptation efforts. Yes, Johanna, please.
Thank you. Yeah, I think particularly you're talking about the finance part. I think by showing, sort of linking it to the discussion that was had earlier today on nature-based solutions, and the conference that was held, or the workshop that was held on blue carbon, what are those type of solutions in the Baltic region? Could HELCOM become a link, or be a platform to be a link between where we have finance that could be steered towards these type of solutions, to gather actors that are working on the topic that might need the money flowing in? I'm also thinking about the upcoming EU nature restoration law, where we will have to see a lot of restoration taking place in the EU and specifically in the Baltic region. But we also need to have finance directed towards us. Could HELCOM be a platform that could link those type of actors potentially? Thank you.
Thank you. Do we have any further comments from the panel on HELCOM's role in knowledge exchange? Yes, Marcus, please.
I would like to refer here actually to the international platform. So Baltic Earth is part of GVEC, that's the Global Energy and Water Exchange Experiment under the World Research Climate Program. So there are several regional programs. And Baltic Earth is regularly reporting what we are doing in the Baltic Sea region to the other regional programs. And there it has been highlighted that this is really unique. And I really think that what is going on in the Baltic Sea, so the interaction between scientists and stakeholders, HELCOM and so on, can be exported. So this idea, because here it's really a great success story, but we need to be a little bit careful and not believe that we can just copy one-to-one the findings of the assessment and the consequent conclusion about climate adaptation mitigation to the other regions, because the Baltic Sea is special. So it is more that we can learn how we do it, and some basics behind, and then we should definitely do that. And I think that could be really a good success story then worldwide. Thank you.
Thank you. Then I would like to take up a question that we got in here that deals with the other kinds of knowledge exchange, and in this case, the optimizing of data exchange. So this might be direct it quite a lot to Marcus and possibly also the national representatives. And is there more need for optimizing data exchange of marine measurement data by regulating data exchange internationally and opening data access to everybody for free in order to kind of allow everyone in the region access to the best available information to support their decision making, thus hopefully then, I guess, making the measures that we put in place more effective?
So it's a difficult question. I think the Baltic Sea region is quite good. So both in the observational data, but also in providing climate model data that can be downloaded from different servers. So if there is a need for data, I think everybody can get this, but these are data provided from science, right? And there is still a lot of things to do in my mind to provide data in a way that it could be used for decision making. And that is really advanced maps, so derivative products of data that could be produced. And here I think it's still the bottleneck that one has to work with that, and with databases that help the interpretation of that. So the raw data is there. There are many good examples, but I think something where interactively data products can be downloaded, that is still rare. Thank you.
Thank you. Then Henna, please.
Yes, thank you. I completely agree with Marcus that I think in the Baltic Sea region we have a fairly good situation with the data exchange and possibilities for data exchange. There are many data services and map services, and even one could say even too many sometimes, that there are so many possibilities for getting data that it's sometimes a bit confusing. But there are many possibilities, and I think we're very good in that sense. And I think many countries are also working with that. At least in Finland, we are in the process of making a new data service, and where even better like data products can be obtained. But I also agree with Marcus that these derivatives of data and that or like clear presentations of different phenomena. So there we have place for improvement. But I think the data is out there really. Thank you.
Thank you. Rüdiger, please.
Thank you very much. So I'm by no means a data expert, that's for sure. But what I can say, and there are two sides to this now, I think, and this has been underscored by both Marcus and Henna, HELCOM is something of a front runner in that regard. And this is something that I see reflected in the reactions of people from other regions, regional seas conventions, or just generally from other regions who actually take a great interest in what we're doing here in HELCOM and try to learn from what is being done and what has been achieved in HELCOM, and are often duly impressed by it. But there's always the other side to it, and I always like to stress that we should never be self-congratulatory. Of course, there is always room for improvement, and Henna and Marcus have just outlined much better than I ever could where that room for improvement exists. So yes, I think we're doing pretty well, and yes, I think we can do better.
Thank you. Then we have several questions here that relate to blue carbon. And unfortunately, we don't have Manuela now on the panel, but I will bring some of these up and see if there is some perspectives that can be kind of brought to the table by the panelists. And one is that relates to fish stock management, and it's healthy fish stocks help drive the ocean's biological pump, and the biological pump that captures and stores carbon, and thus helps us to protect against climate change and supports climate change mitigation. And calculating fish stock contribution to carbon sequestration has made great gains in recent years. is better fisheries management identified as beneficial to protecting blue carbon in the Baltic? And I think this also goes primarily to the national representatives here. And I would ask, is this something that you are aware has been taken up in the discussions on how to identify climate mitigation measures and blue carbon? Marcus, please.
I can start a little bit with the science perspective. I cannot answer this political aspect here. I think there's still a big knowledge gap about carbon sequestration, blue carbon, how that does it contribute to the overall budget? How effective is these efforts? I think it is. It could be a minor part, it could be a larger part. It is, we simply have to admit it's unknown. We got another question, and I take it now, Jannika, if you allow, during my talk. Actually, in one of my bubbles, I had a plus and a minus under carbon sequestration when I showed the second last slide. And this was actually carbon sequestration on land. That was the green dark color. And what it means is it is a study from the entire Pan-Arctic, where it was found that for the coming 50 years, carbon sequestration in unmanaged land areas will increase until about 2050. And after that, the storage capacity is declining, so there's a negative. That is just as a background information. So I think there's a lot of research still needed, and about the carbon sequestration in the sea, in the coastal areas, and all the measurements. They're certainly very useful, but how much it is in total, we do not know.
Thank you. That's very valuable perspective, because especially when we're looking forward, a lot of the questions are related to not what we know, but what we don't know and need to know, even though we just discussed the fact that we need to take action, even in the absence of knowledge. Evia, please.
Yes, thank you. I wouldn't say that I don't have the information, scientific information about calculations about this impact of fisheries management on blue carbon, but I think this issue can be directly connected to marine protected areas, which is also a policy of Baltic Sea Action Plan and also EU policy, that these marine protected areas is directly connected with seabed protection. And as we know also from this morning presentation of Manuela, that seabed protection is also as connected to that blue carbon. I think this aspect is important, and also should be included also this fisheries management, a sustainable fishery, and protecting of these spawning areas of fish, and also is issue that is connected with this climate change. Thank you.
Thank you. Henna, please.
Thank you. Well, I don't have a direct answer to the question, but I would also like to point out that I think that we generally know still too little about the whole carbon cycling in the Baltic Sea ecosystem. So I'm glad to hear if there are like fisheries, the studies with fisheries perspective. Unfortunately, I don't know them myself, but in general, there is a knowledge gap definitely in the whole carbon cycling in the ecosystem, and that's where we need to do more science and gain more knowledge in order to do the right thing, so to say. Thank you.
Thank you. And then we just about have time, I think, for a last question that is directed, I think, directly to Marcus, relating to the presentation that you gave earlier, and it relates to the hypoxia situation. So how was the 19th century hypoxia situation determined, and especially how was the areal extent determined?
Actually, There are two methods possible. So we have since the end of the 19th century Winkler titration and oxygen measurements, but there are just a few. And you do this extrapolation from these few stations to the topography, and then estimate the area below a certain depth, which of the sea bottoms are hypoxic or anoxic. That's one way to do it. The figure that I've shown is actually a model-based reconstruction, and it shows the results of a physical biogeochemical model forced under conditions that we believe happened 100 years ago. Both the model-based reconstruction and these data-based extrapolation estimates give approximately the same results. So at the beginning of the 20th century, maybe the big holes have been hypoxic as well. And maybe the model has here underestimated a little bit the extent, but overall that there is a tremendous jump during the 50s to this high extent that we have now are indicated by both methods. Thank you.
Okay, thank you everyone. And I would like to thank the panel for taking up such a wide variety of questions and being agile and ready for anything, which is always a little bit exciting when you're on a panel where the questions come directly from the audience. Hopefully the audience, as the stakeholders, also found the discussion and the presentations that we had today useful. Now, coming back to this question on what is the added value of regional level work to climate change mitigation, I think as a summary of what we have heard today, there are actually a lot of regional specificities for the Baltic Sea. The Baltic Sea is a unique sea. There is nothing like it anywhere else in the world. And in addition to this, there's also, it's a highly used sea, so it's under a lot of additional stresses. And this means that there is a need to take this regional perspective in order to properly understand what it is that we can expect in the future and how we best address it, not just for one sector at a time, so not just for one type of activity or for one pressure such as climate change, but across the whole spectrum. Because in the end, the ecosystem doesn't recognize the different boxes that we like to place it in order to make our management actions easier. Another benefit that comes from this regional level work on climate change is that the marine environment is getting more focused through incorporating climate change in HELCOM's work. The marine environment in climate change work is often overlooked, not necessarily from the science side, but when it comes to actual mitigation measures, because it's not the direct habitat of us humans. So we aren't as aware of the changes that are occurring in the seas and the oceans. And we also don't have as good of an understanding of how we could use it to improve mitigation efforts. Now, when it comes to this, how much do we or don't we know? It's been made clear, I think, by the panel that taking action on little knowledge is something that we have to do, but that we do actually have quite a lot of knowledge for the Baltic Sea. We might not have the precise knowledge that sometimes makes us feel comfortable when we take decisions, but we do have knowledge to base those decisions on. There's also a lot of data available, so an area where we could do better in order to speed up mitigation would be to use all of that data and make it into something that is more actionable and can be translated into actual mitigation and adaptation measures. And the reason we have to do this as fast as possible is, of course, because if we wait for too long, it might be too late to actually react. And this is where we come to the next step. So how do we kind of leverage action? I think the point raised by Johanna in the panel discussion is very important and something that should lead regional level work, which is what is the cost of inaction? So if we do nothing, what does that cost us? This is a perspective that is actually quite uncommon in regional level work, where often we look at it the other way. What is the cost of the actions that we're taking? But we haven't, we've only recently started looking at it the other way. And of course, when you change your perspective, that takes a change in mindset, but also a change in kind of how you present the information that you have. This can then be taken on into this discussion on incentives. So i.e. follow the money and see where are we channeling the resources, and are they going to activities and businesses that are actually contributing to mitigating climate change, or are we either knowingly or unknowingly working against our own needs by channeling resources where maybe they shouldn't be going? Because the truth is that the less mitigation that we do, the more adaptation we will have to do later, as also brought up by the panelists. And we know from over 40 years of HELCOM experience that measures that address something that has already happened is far more costly, far more resource intensive, and much more difficult to do than when you take measures to stop something from happening in the first place. So in order to make the limited resources that we have to address climate change reach as far as possible, they should target mitigation above adaptation wherever possible. But in order for this to actually happen, climate change needs to remain high on the political agenda, and not just climate change overall, but climate change for the Baltic Sea region and specifically for the marine environment. This can be strengthened by finding these win-win solutions where we can show that climate change mitigation carries other positive side effects with it. Because this will also help keep climate change mitigation implementation stable, even in a changing political climate. And this can further be supported by having an informed public. So here it was brought up by the panelists that this kind of knowledge exchange needs to be done both specifically where it's targeted and supports direct mitigation, but also on a general level where the cost of inaction, for example, needs to be shared with the general public so that they understand the consequences of the decisions that are being taken. Then it was raised that it's important to also follow up on these mitigation measures, because if we take a measure, we need to actually understand if it's having the effect that we are hoping that it's supposed to have. And the only way to really do this is through assessments. So on the one hand side, we need to implement measures. We need to make sure that the level of implementation is high enough and that there is a strong commitment by the countries around the Baltic Sea, but also see that that commitment is translated into actual effects in the environment that then give us positive effects and mitigates climate. And while HELCOM might not be the forum for mitigation targets, HELCOM can contribute to the processes that are surrounding reaching these targets. Because climate change neutrality needs to be done jointly with addressing the biodiversity and pollution issues that we're facing. It's not a single challenge that we're facing. We have this trifecta, if you will, of challenges that are enforcing each other. So by tackling one, we also tackle the others, but we need to understand the dynamics between these. And this is done by taking a holistic perspective to the actions that we're taking. So if we take a climate change mitigation measures, measure what is the effect for other parts of the system. And this is important because ultimately we need these mitigation measures to increase resilience, because the climate will be changing, as we could see through the presentations earlier today. Even if we would take all of our action right now, we will still see a change. So we need to increase the resilience of the system against these both gradual changes and extreme events. And HELCOM actions contribute to doing this because they address both biodiversity actions. It also addresses eutrophication and pollution actions, and our direct activities. So what we're doing that is causing these pressures on the environment. I like the point brought up by Evia saying, think globally and act regionally, and HELCOM might not be the forum for mitigation targets. That's something that we set nationally and globally, but they can be implemented on a regional level, because what one country does in this region has a direct impact on all the other countries. We are running out of time now, both in this today's event, but also in relation to climate change. And more than ever, we can't afford to reinvent the wheel over and over again. That's why we need to learn from each other. This was clearly brought up by the panelists, and exchange information on concrete measures, measures that are well adapted for Baltic Sea conditions and are implementable across the region. And this regional level work is a vital part of this. So I think that would function as my concluding remarks for today's event. I would like to thank all of the presenters and the panelists and all of you as participants. And I hope that you have some good take-home messages from this, and also have the possibility to use the climate change fact sheet in the coming years as we continue our efforts to take action on mitigating climate change. And for those of you who will be joining tomorrow's or dedicated workshops, I would like to remind you that we start at 10 o'clock in Eastern European summertime, and 9 o'clock for the rest of the Baltic. We will make the recording available and also provide the outcome of today's event on the conference website. Thank you, everyone. It has been a pleasure for me to moderate this event, and I look forward to seeing some of you again tomorrow.